Welcome to Microsoft Build 2017. In this session, you will learn how to protect you and everyone you love from despair. And by despair, I mean serious issues in your code that could allow an attacker to take over your computer. My name is David Molnar. I will show you how to fuzz it, Microsoft Security Risk Detection in Practice, a new offering from Microsoft that helps you find serious issues in your code. Now, before we go further, just to give you a little level set, this is a 200 level session. I will show you a sample code written in C++ that has issues, and I will show you how to use Microsoft Security Risk Detection to find those issues, and then I will show you some specific things you can do with the Microsoft platform to fix those issues. You do not need to be a security expert to benefit. It will help if you have a basic knowledge of C++ and some basic background in how security attacks happen in code, although I will cover it briefly as we go forward. The basic thing that we do in Microsoft Security Risk Detection is we enable you as the developer to take your code, upload it to a machine that we provide. You show us how to run it. You show us some test cases, which I will demonstrate here. And then we create an entire testing lab just for you, including artificial intelligence that Microsoft has been working on for over a decade that's been used on Windows and Office, and a portfolio of other things that are pretty good at finding security issues. And you don't need to know how they work. We have other sessions that you can go look at, which will show you more about how they work. We have academic papers that go into even more detail. Or you can find me at Microsoft Build or another Microsoft conference. But the beauty of this is that you can use this technology and scale it out without having to become a security expert. And what we do is we give you a report saying these are the things that we found and how severe we think they are, which you're going to see in a minute, and you can take action. And of course, the best action would be to fix the bug, but I will also show you some features of the Microsoft platform that you can use to reduce the risk if you're not in a position to actually fix the bug at the moment. So without further ado, I'd like to sort of start walking you through our code sample. So imagine that you have decided to write a calendar application. And a calendar application is something pretty simple in theory. It takes in some calendar entries and it outputs different changes that need to be made to our shared calendars. And it might look something like this. I have already built it for us. And so you can see here, I'm going to a calendar reader. I want the minimal calendar. So all it says is the number of entries, the type. It's from a colleague of mine here at Microsoft, the time, duration, and everything else is null. And in fact, I have a number of different calendars that have been created already for this calendar library. Now, as developers, we would see, well, what is the code that actually handles this calendar? Well, I'm going to open up the code now in Visual Studio 2017 so you can see it. So the code in Visual Studio 2017 is a library written in C++. Maybe it needed to be fast. Maybe we got it from a colleague who enjoys writing C++. Maybe the origins of this are lost in the mists of time. But you can imagine that this is something you've been given and said you have to write something that uses this library. How often have we all had to deal with code that wasn't originally ours? And so I can say, all right, here's the calendar structures. And I can start looking at this is what the format looks like in code. There are a bunch of structs. And I can go back and say, if I take a look at that minimal calendar, yep, it's some kind of binary file format. So this is an example of code that's reading and writing a binary file format inside of a library. And what I have also put together for you is this calendar reader, which is a sample application that reads and writes these calendar entries. Let me show you what that looks like. So calendar reader is down here, and we have a little calendar reader CPP. And it's got a main, which I can go to, and I can show you that it creates a handle, it gets a calendar from file name, and then it starts using the library to understand what's happening inside the calendar. Now, one of the things that's exciting about this code sample is we've actually planted serious security issues in it. Let me show you two of them right now. Visual Studio has a feature called Code Analysis that is in Visual Studio Community 2017. And it will try to tell you about certain issues that you might see in the code that could be security issues or otherwise software quality issues. So I'm going to go to Build, and I'm going to run code analysis on the solution. And it'll just take just a second here. And it's going to build the whole thing, and it's going to go through and read the code faster than I can, because I'm actually not that fast at reading code, I have to tell you. And we're using that to understand what's happening inside of this application. And while it's doing that, I'll just go through and I'll show you what exactly it is that we're looking for. We have put into this, for your enjoyment, specific bugs, complete with descriptions of the bug and explanation of how they are triggered. So as you saw, we just ran the code on a simple example, and none of these bugs got triggered. The code didn't crash. We didn't see anything wrong happen. But there are latent bugs in this code just waiting to come out and bite you. For example, this is a bug that says, hey, I have a string that's passed to printf. And if the string contains format specifiers, that string may end up reading data from the stack. In fact, it may end up reading data from the stack that isn't allocated, causing a crash. Or worse, it may end up reading or writing data to the stack that could allow for code execution. So this is an impact where a skilled attacker can exploit this and gain arbitrary code execution. Now, going through the details of that are outside the scope of this session, but you can find out more about this using some of the links that we include in the documentation center that I'll show a link to at the end of this talk. Well, now I've gone through and the stack analysis, the code analysis is run through, and it says, oh, you might have a null pointer dereference. So I'm going to go click on that and say what's going on here. And it'll come up here in just a second, and it'll tell me that I have a null pointer dereference, and it's going to give me a whole bunch of reasons why the null pointer might be being hit here. And it does a great job of highlighting all this. So it's going to tell me, oh, you know, this is a current entry. This thing might not actually have been populated if I go through and I go up the entire chain of reasoning. But here's the thing. This code analysis, as wonderful as it is only finding 2 out of the 10 issues that we've planted in this code. We need to find more issues. And the other thing, this code analysis is fantastic. Everyone should use it. But as you can see, it's giving me some warnings I have to reason about. Wouldn't it be better if I actually had a test case that I could see that would cause us to crash? Well, that's what we provide for you with Microsoft Security Risk Detection. I'm going to show you now the actual product itself, and I'm going to walk through how we would upload this calendar reader to Microsoft Security Risk Detection and show you what it looks like on the other side. So Microsoft Security Risk Detection is provided as a web application with a front end that lets you manage all the pieces of code you're going to test. So I'm going to show you the preview URL that we have. We will have a final URL later, and please reach out and sign up using the link that you'll see at the end so that you can understand and get that final URL. An exciting feature of this preview URL is that we've decided to pick a place name, so it'd be something that wouldn't overlap with other products out there in the world. I happened to used to live in Las Vegas, so you'll notice it's Alamo Hendersonville. Well, I used to live pretty near Hendersonville in Las Vegas. That's just one of those little pieces of color we get to do here at Microsoft when we're building new things and getting them out to you. So I'm logging in. I can use my Microsoft account. I can also use my Azure Active Directory account. So that depends on which way I want to manage this or which way you want to manage this in your organization. You can share this account between multiple people in your organization so that if you need to have a whole team of people all working on the same code, you can do that. So I here have a list of different pieces of code that are being tested. And we're using a technique called Fuzz testing where we throw unexpected inputs at the problem. So you can see here, this is an application I've already submitted. I'm going to show you that first so you can see what you'll get from this. And then I will show you how we prepare the application, exactly how it's uploaded and how you can get into the system. So first of all, I'm going to look at the results page. The results shows you everything that Microsoft Security Risk Detection has found so far. So remember, I showed you that graphic. what you get with this is a whole lab running in Azure, just pounding away at your code incessantly, day and night, nonstop, looking for things, looking for test cases that will cause it to crash to give it to you. And when the lab finds something, you get a report that looks like this saying, here are the things that security risk detection has found, that you can download test cases and you can download the results from running the Windows debugger so you can understand which ones you want to fix first. And you can actually filter these things as well. So I want to filter just the crashes. And this has just started. We expect it'll find more stuff, but so far it's already found what we call a read access violation. And that's something that our heuristics, our sort of best guess says this is a potentially exploitable issue. This is something you should take seriously. And what's happened is you can download here the actual test cases that cause the crash. So you can download them, and it will just sort of take a minute, zip up all the test cases that have been found that cause that issue for your enjoyment. And then, yep, I can save it, and I can open it. And then what happens is I can see, here's all these cal files. So remember, you're seeing a code sample for a .cal file, a calendar reader, a calendar library. Well, this is just showing you those files that were causing crashes. And to save us some time, I've actually already just taken one of them and I've copied over into the directory of the calendar reader. And I can say, oh, calendar reader. And with the magic of autocomplete, there you go. And it crashes. So we've found a serious crash. And this is something that then you can load into your debugger. You can see exactly where it went wrong and exactly what you can do with it. So I'm going to close program rather than debug right here so I can show you exactly how you would get up to the point where you get this back. So now you've seen what the results look like. You've seen that gives you a test case that actually crashes. And you've seen that it tells you like which ones are security critical and which ones are not. But you don't actually have to know about security in order for that to happen. You just need to know how to debug. So let me show you how you can get up and running on security risk detection. I have a job, that's what we call it. A job is a specific application you want to test that's going to turn into a lab in the cloud. I have one right here, already created for you, that you can use in order to go after your application. And the way you use this is you connect to it with remote desktop and you can install whatever you want. You can install kernel drivers, you can change the registry, you can install SQL Server. Anything you need to install, you can install on here. And so it's going to let you connect to the virtual machine. And here we go. I've got my remote desktop connection. I'm downloading this little file here, which will let you connect to it. I'm saving that. I'm opening it up. And then what you will see here is after you connect, I'm going to copy a password here so I can get in there. I copy that, paste the password. So every machine has a long, unique password so that no one else can get into your job. And what you will see here in a second is our wizard that will help you guide through the process of getting your software up and running on security risk detection. So I'm going to go ahead and connect. And it'll just take a second here to connect. But remember, what we're doing here is we're creating an entire virtual machine in the cloud where you can take everything you need, all your dependencies, bundle it up, and deploy it just the way you would deploy to any other machine in the cloud. So for example, over here, I've got my calendar reader. I've got my calendar library. And what you can do now is say, okay, I need to know what those dependencies are. I've actually already, to help us, I've already gone through and wrap them up into a zip file that I can just copy and paste over. And let's see, that is, I can actually, I've called it deploy here. So I'm going to just, once we log in here, so now you see the wizard. It's called the Microsoft Security Risk Detection Wizard. We are the evolution of a project called Springfield, which is why you say welcome to Springfield here. Some of you who were at Ignite 2016 may have seen our Project Springfield preview. We are now available commercially as a full Microsoft offering. And what we can do here is copy and paste your code directly into the virtual machine. So I'm going to go ahead and move the computer here. And I can just, because this is something that's just in a single zip file, I can just copy and paste. But there is also a way, if you need to mount a local drive, or of course, this machine actually has access to the internet, and you can download things from the internet if you need to in order to set up your code and your applications. For example, we've helped customers in the past set up Azure storage accounts that can be used as staging in order to get bits from your on-premise build accounts into this particular machine without having to give this machine access to any of your super secret corporate internal stuff. So I am going to deploy this. I'm going to extract it. And what you see here is I've got a bunch of seed files. Seed files are just sample inputs. In this case, these are sample calendar files, just like the one you saw. So if you're doing regression testing or if you have some functional testing of your application, this is what you would put in there. So I have my seed files, and we provide for you in the code sample files are already valid and files that are already known to crash, so you can see the crashes ahead of time, even before you have access to security risk detection. And then if I go here, I see, oh, I've got this, and I've got a binary, I've got the release, and there's my calendar reader. That's the application that you want to test in this code sample. You want to go after that calendar reader. It's wrapping up this library that you have to deal with, that you need to know if it's secure or not. You need to know if this is something I need to pay special attention to or call in help with. Well, there it is. That's the reader. And so what we do is we've wrapped up kind of all of the questions that you would need to answer for doing security testing, fuzz testing of this application for you into this wizard. So the wizard says, okay, install everything, click next. Well, it wants to know where the program is that we want to test. Where's the program at the entry point we're going to test? Well, I just uploaded it for you. So I'm going to go ahead and I'm going to go look at deploy. I'm going to go here. And I know it's in the binary, it's in the release, calendar reader. That's what I want, calendar reader. And the command line arguments, this program, remember, you saw this program just takes one argument. It just takes the name of the file that we're going to read. Now, your code may have many different arguments, many different applications, or many different sub parsers or sub-applications you want to look at. This is your opportunity to change the command line that's passed in order to get exactly what you want to test. So we go next. And the seed files, well, that's just, as I showed you, that's just the sample inputs to the application. And I've already uploaded those. Those are in deploy, they're in seeds, and we give you these valid seeds which don't crash the application, but they can be used as a starting point for the testing. So say OK, say next. And then you can answer some questions about your application. These are not security-related questions, but they're questions that you can understand just by looking at how you built the application. So can this executable be renamed and run in parallel? Well, yes. This code sample doesn't have any global locks or anything that prevents it from running multiple cases in the same machine. Does it run from scratch each time? For example, there are applications that will change the registry every time they run. The code sample is not one of those. You can have an independent run. Does the executable run entirely in one process or process tree? Or is this something like a multi-tier application where you have maybe a SQL server and a web front end and all that stuff? This code sample is a single application. You're just wrapping the library you want to test with the calendar reader. So next. Does it self-terminate, or do you need to close it? For example, we spent years and years testing GUI applications like Word that don't necessarily close themselves when they're done opening the file. In that case, you provide a timeout and say, I want you to sort of kill this application after 5 seconds, no matter what happens. And then we'll see what kind of security issues we find during that time. This particular application, this code sample, as you saw, closes itself automatically. And then this helps us understand, is there a length of time after which you'd like to be notified? Like maybe there's a resource exhaustion issue, or maybe it's a hang. So if you're building a library that's going to get embedded in the cloud service, this is something you might be really interested in because it affects your availability. Wouldn't it be bad if your cloud service just started using all the CPU and not handling people's requests for some reason? Well, you can use this timeout to help you catch those issues and report them as well. All right, we're just about done. But the submit button is grayed out. Why is the submit button grayed out? Well, it's grayed out because you need to actually check that everything worked. The wizard will say, you need to validate this job. You can check, before you spin up an entire lab in the cloud, you can actually check to make sure everything is working properly. So I'm going to push that little button, and I'm just going to look at this and sort of see what happens. And oh, I can see something's happening down there. And oh boy. Well, it didn't work. Why didn't it work? Well, if you look at this, it says, I can't start because MSVCP 140 DLL is missing from your computer. That's right. It's Visual Studio 2017. And I didn't install the redistributable. Whoops. How often does that happen where, like, you're trying to do something and deploy something and you just forget that one little thing? Well, spoiler alert, I actually knew that was going to happen. So I went ahead and I have already pre-downloaded for you the VC redistributable that's required. And I'm just going to go ahead and paste it, copy and paste. So you can see Remote Desktop allows you to copy and paste files. Again, if it's a bigger file, I would use the features of Remote Desktop to mount my local drives, or I would set up an Azure storage as a staging environment where I could upload things from my premises here into the cloud, and then this application, this VM could then pull it off of there without having any access to any of my other resources here on premise. All right, so let's see. You have to install things it depends on. Who would have thought? But fortunately, this is a very quick install. And it's something that we're going to go ahead, try it out, install it, and then once it's installed, you can validate again. You can validate as many times as you want. That way you know you've got the right configuration before you send it off to the cloud. All right, so there you go. SEP is successful. I'm going to validate the job. And under the hood, what you're seeing is that it's running the application with the parameters that you provided it to make sure it's doing the right thing for you before we go off and create an entire army of Azure machines just for you. Oh, it's done. So it actually is done already. That's great. You can now press submit. You can press submit and get an army of Azure machines working for you using the best technology Microsoft has, looking for issues in your code. And we just push the button, and it's going to make some progress. And at this point, you can just go ahead and close the machine. It will go through a whole process of further validation. I don't want to waste your time with all of that, but now it's done. You can just let it go and relax. And then, as you saw, you will get those issues. You will get the severity of those issues, and you will get the ability to download test cases that show you where the crash happened. So now, if you think back to our sort of wheel here, you've seen how to upload the binaries. You've seen multiple fuzzers get started. And again, there are other sessions you can go to which will tell you more about the under the hood of Springfield. And then you've seen the high-value bugs and how you can get the test cases. So finally, there's just to take action. How do you deal with this? So you've already seen this. This code sample is not in the world's best security shape. What are you going to do? Well, of course, clearly the best thing to do would be to fix all the bugs. You don't have time, and I don't have time to sit down here and debug everything in this code sample. You can go and read the code sample and fix it yourself right after this talk. Feel free to do that. But I want to show you just one example of the vast array of things the Microsoft platform has to help people like you in a case like this. So Microsoft, starting Windows 8.1 and improved in Windows 10, has a feature called Control Flow Guard, which is available to everyone using Visual Studio on the recent Windows platforms. And I'm just going to show you how to turn it on. Control Flow Guard doesn't get rid of these bugs, but what Control Flow Guard does is it makes it harder for an attacker to use the bugs to hurt the people you care about. So Control Flow Guard does a whole bunch of important analysis of your program to say, hey, this is where you were probably intending the program to execute. And when someone tries to use these bugs to take over your computer, quite often they end up forcing your program to execute in a place that was not originally intended. And so this is, control flow guard is what they call a mitigation technique. It doesn't prevent all the bugs, it just makes them harder to stop, harder for an attacker to use. And it's really simple to turn on. We're going to go to our project properties. I'm going to go to my C++, so you can see here, C++ project property. You can do this right now. You can turn this on anything else you have. Code generation, and all right, I want to enable the security check. That's on by default for most applications, but the thing that's not necessarily on by default is control flow guard. So this is something, it does have potential compatibility implications. You'll see a pointer at the end of this talk to a website that explains much more in detail about that, and you can learn more about that. So you have to test it. But this is a very simple thing that you can do right now with this code sample and say, oh, you know, I know there's some risk here. What can I do to turn on some mitigations? And then I will show you at the end how you can look at an entire blog post about other mitigations built into Windows 10 that will help you contain the risk as well. All right, so you've seen Microsoft Security Risk Detection told you there's an issue. Now you've seen you can turn on Control Flow Guard. I'm going to say OK. I'm going to go ahead and build my solution. I'm now rebuilding it. I'm adding this feature. Visual Studio is doing some magic under the hood to help you be more safe against security issues. And it's up to date. And then I'll just go back here, and it's still going to crash when I run the test case. But now, under the hood, it has more protections to prevent someone from taking advantage of it. So, and you can see it still runs just great. So to recap, what you've seen today, you've seen how to upload binaries. You've seen how we can create a lab with multiple fuzzers, and you can go look at other sessions to understand more about how that works under the hood. There is another session called Under the Hood of Security Risk Detection that you can go look at to see exactly what's happening when I'm pushing all those buttons. You've seen what the bug reports look like. You've seen that you can get a real test case that you can use or you can give to your team. You can attach it to your Team Foundation server, your Visual Studio Team Services, or whatever the bug tracking system is that you use. And you can give people direct, actionable feedback saying this thing crashes and you need to fix it. And then you've seen that in addition to fixing the bugs, you've seen a taster of the many features in the Microsoft platform that will help you contain risk. So to close, you can sign up today for Microsoft Security Risk Detection. Microsoft Security Risk Detection will be available in summer 2017 in North America broadly. You can sign up today to be one of the first to be contacted when it is. The sample code you saw, you know, you didn't have time to see a lot of it, but you can go download it right now and study it at your leisure from docs.microsoft.com ENUS Security Risk Detection. You will learn about the specific issues we planted. You will see about the kind of things that security risk detection can find and what it can't find. And you will get an entire dump of all of the documentation of how to use security risk detection in your context. And then you can learn more about the threat mitigations like Control Flow Guard that I showed you at this blog post. And again, we have other sessions on security risk detection and on security and development that you can see on Channel 9. So with that, I thank you for your time, and I look forward to helping you become more secure and helping you protect the people you care about. Thank you.